Students, we are given this question. We are expected to find the modulus and the principal argument. So the key word is principal argument. Have it in mind. For this complex number, z to be equal to root of 3 positive I. Now you write down the formula. We know that if z is equal to x positive iy, then modulus of z is equal to root of x squared positive y squared. This is the formula we know. So therefore, modulus of z is equal to modulus of the complex number root of 3 positive I, which is equal to root of square this root of 3, and to it you add the square of the imaginary part. This is going to give us root of 3 positive 1, which is equal to root of 4, which is equal to 2. You only take the positive side of the modulus. So therefore you can write it down that mod of z is equal to 2. So this is fine. Now from here we know that clearly we know that x is equal to root of 3 and y is equal to 1. So therefore alpha, we are not finding theta because theta is a principal argument. We can only find alpha from this complex number. So alpha is equal to tan inverse of y divided by x, which is equal to tan inverse of 1 over root 3. Now this value we know to be as pi over 6. So alpha is equal to pi over 6. So if you were to plot the alpha, alpha would be in the first quadrant. Okay. Now since alpha is in the first quadrant, we know that theta is equal to alpha. This is the imaginary part. So therefore the principal argument is pi over 6 and the modulus is given to be as 2, and that completes the solution for this question. Students, we are given this next question. We are expected to find the modulus and the principal argument for this. So therefore clearly mod of z is going to be root of negative root of 3 raised to the power 2 positive 1 raised to the power 2. This is equal to root of negative root 3 squared will give me 3 added with 1, which is going to be root of 4, which is going to be equal to 2. So modulus of z is equal to 2. Now clearly we also see that you can write it down here. Also x is equal to negative root 3 and we have y to be equal to 1. So alpha is tan inverse of y over x, which is equal to tan inverse of my y is 1 but my x is negative root of 3. So this means if you were to draw the Argan diagram, this is real axis, imaginary axis, the negative root 3 would be present on the negative part of this axis. So it's going to be on this side. Now since the modulus or the amplitude is 2 units, you can stretch 2 units from the origin and you can locate the complex number to be somewhere over here. Okay, this would be the presence of this complex number, negative root 3 positive I. But we are sure that the principal argument has to be found. Now in this case, if you were to see, the alpha occurs on the second quadrant. In this case, alpha is equal to tan inverse of y over x. We cannot simply place the value of y and x here. It has to be placed within the modulus sign. Now once we place it in the modulus sign, we get the value to be as pi over 6. Students, because the quantity involving the complex number has got a negative sign here, because of that we got theta to be equal to pi negative alpha. Okay, so in other words, my theta will be moving on this side. Of course my alpha will be over here, and alpha is pi over 6 and the value of theta has to be found. Theta is 180 minus pi over 6, that's going to be 30 degrees, and that will give me 150 degrees, which is nothing but 5 pi over 6. So theta is 5 pi over 6 and the magnitude is equal to 2. So this completes the solution to this question. Students, we are given this question. Z is negative root 3 negative y. We are expected to find the modulus and the principal argument. Now clearly from here, modulus of z is equal to root of negative root 3 raised to the power 2, positive negative 1 raised to the power 2. This is equal to 3 positive 1, which is equal to root of 4, which is equal to 2. So therefore the modulus of this complex number is 2. Now we have to find the alpha value. So alpha has to be found. Alpha is tan inverse of y over x. Now clearly from here we can write x to be equal to negative root 3 and y is equal to negative 1. So therefore alpha is equal to tan inverse of, now y is negative 1 and x is negative root 3. Now this goes within the modulus sign, so have that in mind. So that means this is tan inverse of 1 over root 3. So this is going to be giving us a value of pi over 6. Now this cannot be taken to be as our principal argument. Now foremost, you have to represent the complex number on the Argan plane. So let us do that. Now when you see the complex number, it has got a negative quantity for x and a negative quantity for y. So that means you have a negative quantity for x, that means the negative side of the real axis, and a negative quantity, that means a negative part of the imaginary axis. So the complex number would be featuring over here. Magnitude is given to be as 2 units. So you have to stretch from the origin 2 units. Okay, so this will be r is equal to 2. Anyway, the most important part, since I know the argument or the amplitude is present on the third quadrant, I know the value of theta is got by subtracting alpha minus pi. So alpha minus pi would give me the value of theta. So in this case my alpha is 30 degrees and my pi is 180. So that is going to be negative 150. If I were to write it in terms of radians, it's going to be negative 5 pi over 6. So this is my principal argument. So I've got the principal argument, theta is equal to negative 5 pi over 6 and the modulus, which is 2 units. So that completes the solution for this question. However, if you want to represent theta, theta would be taken in this direction. Okay, and you can write down theta to be equal to alpha minus pi, and in the case of alpha, alpha would be featuring from here, and that completes the solution to this question. In fact, you can just place the complex number negative root 3 negative I is equal to z. So this is the complete solution for this question. Students, were given this question, z is equal to root of 3 negative I. We are expected to find the modulus and the principal argument. Clearly from here the modulus is going to be root of squaring root 3 and then to it adding the square of negative 1. This is going to be root of 3 positive 1, which is equal to root of 4, which is equal to 2. So the modulus of this complex number is 2 units. I have found that out. Now we have to use the Argan diagram or Argan plane in representing the complex number. So this is root 3 negative I, so that means 3 units along the positive, root 3 units along the positive side of the real axis, so that's going to be here, and negative 1 unit is going to be down. So complex number will be featuring somewhere over here, so r is equal to 2 units here, and let me write down the complex number. Z is equal to root of 3 negative I. So this will be the location of the complex number. So the complex number is located on the 4th quadrant. So that means we need to take the principal argument theta to be as negative alpha. So therefore theta is negative alpha. And we have to know what is alpha. Alpha is tan inverse of y divided by x. And x is equal to root 3 here and y is equal to negative 1. So therefore alpha is equal to tan inverse of -1 divided by root 3, but this has to go in the modulus, so that's going to be tan inverse of 1 over root 3, which is pi over 6. So therefore the value, let me write down the value of alpha. Alpha is pi over 6. Okay, alpha is pi over 6, so this means theta is negative alpha, which is negative pi over 6. So you can write theta to be as negative pi over 6, which is the final answer to the question.